We'll do 3 case studies using the ANSYS finite element analysis solver, which uses the finite element method. And before we get into the ANSYS finite element solver, we need to understand the major elements of what's under the black box so that we can move beyond just pushing buttons and use the tool effectively. In particular, we need to understand the strategy used by the finite element tool to solve whatever mathematical model we give it, and what are the errors introduced in the process, and how do we decrease these errors. And I'm going to present these ideas from the perspective of the tool user rather than the code developer. Whereas, conventional finite element analysis or finite element method introductions tend to present the material from the viewpoint of the code developer. And to figure out what concepts to cover, I've used a just-in-time strategy, which is I've gone through the ANSYS case studies and distilled out what one needs to know as one is working through the tool, what one needs to know about what's under the black box. And I'm going to present these ideas intuitively and visually, so I'm not going to do the derivations rigorously, but intuitively, so that by thinking in an intuitive and visual way, I found that when I'm in the tool, it's effective to figure out what the tool is doing, how do I reduce errors, how do I fix problems, and so on. Whereas on the other hand, I've seen that when one sees the gory detail, I've seen this often with students. It's you see all the gory details of the finite element derivations and so on, and you get to the tool, it's a very different context, and it's hard for us to kind of transfer it from that from the textbook context to the tool context. And so what I'm trying to do here is bridge the two. We will discuss the big ideas in finite element analysis by considering a simple example: one-dimensional heat conduction in a bar. More complex examples that we'll be doing in the ANSYS tool are based on these ideas. And we'll come back to these ideas as we are solving problems in ANSYS. They form the building blocks of the finite element method. So it's important that you understand these ideas well to use the tool effectively. Let me go to my PowerPoint slide. Here's the simple problem that we'll consider. We have a bar of some given length, and we have heat conduction in the bar. We are interested in finding the temperature distribution in the bar due to heat conduction. We'll assume that the problem is steady, that is, the temperature at any point doesn't vary with time. We will also assume that the problem is one-dimensional, and which means that the temperature for any cross-section is the same, and there's no variation of the temperature across the cross-section. So if I put a coordinate system like that, with that being the x direction, that being the y direction, and that being the z direction, I will have variation only in the x direction, and the temperature won't depend on y or z. And once I find the temperature at any point in the cross-section, I know the temperature anywhere in the cross-section. That's what I mean by the one-dimensional problem. And these simplify the equations that we need to solve, and so the details are kept to the minimum as we focus on the big ideas.